A-Level Chemistry Paper 2, Specimen Set 2. So question 1, first of all, gives the initial rate, and it gives the concentration of benzaldehyde, which is this chemical here, and it gives the concentration of benzaldehyde in each of these 5 experiments, and it asks you to calculate the concentration of benzaldehyde squared. So all we do is take 0, square it, 0.25 square it, 0.5 square it, 0.75 square it, and 1 square it, and you come out with answers like that. There are no marks for precision, so you can run it to as many decimal places as you want, really. Plot the graph of this benzaldehyde concentration squared on the grid opposite and label the axis. So it'll come out a little bit like this, where you've got initial rate up the side and benzaldehyde concentration along the bottom. You always do it that way, so something that's fixed in the table goes along the x-axis, so the concentrations here are measured, are sort of laid out at the beginning of the experiment, and these are the results that you take. So the results that you take, like the rate, that aren't fixed concentrations, this is what you're measuring, goes up the side. Deduce the order of reaction with respect to benzaldehyde from the graph. Explain your answer. Well, normally a straight line is first order reaction. So if something's first order reaction, then usually it means that 0 order is a straight horizontal line, first order means it's a straight line going up like this, and second order would be a curve curving up like this. But because you've got squared on the bottom, actually a straight line in this case is showing second order. So normally if it was just concentration of benzaldehyde, a second order reaction would curve up like this. But because you've got a squared here, the squared actually turns it into a straight line. So if the concentration is squared along the bottom and it's a straight line, it's actually second order. So it's second order, and that's because concentration squared plotted against the rate is actually a straight line. If it weren't squared, then it would be a curve bending upwards. Let's have a look at this next one now. The rate equation for the reaction is rate constant multiplied by the concentration of benzaldehyde multiplied by the concentration of some cyanide ions. But actually cyanide ions don't appear in the actual reaction, but they do affect the rate. So that's strange, isn't it? They're not a reactant, but they affect the rate. So explain the role of something that affects the rate, can maybe speed up a reaction, but it actually doesn't appear in the equation at all. Maybe it's there at the beginning and there at the end, maybe it's remade and therefore it can cancel both sides, but it doesn't appear as a reactant or a product in the rate, in the sort of reaction at all, but it does affect the rate. So the role of a Cn- ion is it's a catalyst, and because it appears doesn't appear in the equation but does appear in the rate equation, that means that it's a catalyst.